Hello everyone, my name is Zachary Ware, and for this paper I chose to do the anchoring effect, or the anchoring bias. So to get started, we're going to cover with what a cognitive bias is. A cognitive bias is an error in thinking about or interpretation of information. Certain biases shape the way in which we react to certain events, how we think, or how we see the world. Examples of these biases include, but are not limited to, the clustering illusion, the conservatism bias, or the anchoring bias. For this paper, I'm going to be focusing on the anchoring bias. Anchoring, or focalism, is a term given to the psychological effect where a person often relies too heavily on the initial information presented to them when making decisions. In other words, it is the initial exposure to a number which acts as a reference point for all future judgments. The number in which a person is exposed to does not necessarily have any relationship to the judgment a person must make. That is, the number a person is initially exposed to can be any arbitrary or meaningless number, and it will still influence how the person thinks. The human brain, though powerful, has limitations to how much information can be processed in real time. So when making decisions, although many people like to believe that they always make a well thought out decision and have weighed all options equally, often the decision is influenced by many cognitive biases resulting from an attempt to generalize or simplify the information presented to them. These generalizations and simplifications are often seen as mental shortcuts, otherwise known as heuristics. There's no single cause to any of the cognitive biases, and these cognitive biases are not always seen as a bad thing. These biases allow people to quickly and sometimes accurately make assumptions and draw conclusions when important information may be lacking, and they may even lead people to make decisions quite rapidly. Anchoring is often thought of simply as the initial exposure to a number acting as a reference point, consciously or subconsciously, in a future decision. However, anchoring can have a different meaning as well. Adjustment is a form of anchoring where assumptions are made based on the initial numbers in a sequence, and where through solving the numerical sequence, adjustments are made mentally, effectively just estimating the numbers as the sequence continues. A popular example of the adjustment anchor is an experiment conducted by Daniel Kahneman and Amos Tversky, where two groups of high school students were asked to solve two equations. The first group was given the equation 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. The students were given approximately 5 seconds to solve the problem mentally and to write down their answers. The second group was also given 5 seconds to solve a similar problem. This time, however, it was 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. Though the products of these two problems should be identical, the two groups had, on average, vastly different answers. The mean answers from the first group was 2,250, whereas the mean answer from the second group was only 512. Obviously, however, neither of these answers is correct. The correct answer to both problems is 40,320. The large discrepancy between the two answers is due to how each group adjusted and estimated for their final answers. In the first group, students would see the first part of the problem, 8 by 7, as simple mental computation. From here, they would then multiply the product of 8 and 7, 56, by 6, a slightly more challenging mental computation, but one that can be easily estimated if the initial product, 56, is adjusted to 50, making it easier to work with mentally. Obviously, the answer would have to be larger than 56, and even larger than that, multiplying by the next number and then by each consecutive number, leading the students to believe that the final answer must be very large, such as 2,000. An immediate issue arises, though, in the underestimation of the final product stemming from the first time that a number is adjusted down to a number that is easier to work with, in this case the adjustment from 56 down to 50. In the second group, however, the students first had to multiply 1 times 2, a relatively small product in a simple mental calculation. From here, they had to multiply 2 times 3, again, a relatively small product in a simple mental computation. The presence of relatively small products in the beginning of the math problem led the students in the second group to believe that the final answer must itself be relatively small, perhaps around 500. By analyzing this experiment, we can see that the initial product that the students were anchored to, and by examining how the students adjusted their answers as they went, significantly affected their final estimated product. Dan Ariely conducted an experiment on anchoring at MIT Sloan School of Business by taking a different approach. In this experiment, Ariely asked the students to write down the last two digits of their social security numbers on a piece of paper. He then held an auction in his class. In this auction, students could bid on various items, including a bottle of wine from 1998. The results of this experiment show that students whose social security numbers fell between 80 and 99 bid upwards of 3 times higher than those whose social security numbers fell between 0 and 19. By analyzing these results, we can see clearly that people can and do become anchored to any arbitrary number that they are introduced to. The student's social security numbers should not in any way affect the amount that the student is willing to pay for the item, but due to being anchored to the number subconsciously, the student's willingness to pay more is altered. Another strong example of anchoring is the story of the Pearl King. Salvador Sal learned how to barter Swiss watches for Japanese pearls and made a lucrative business out of it. When approached by a Frenchman, Jean-Claude Broyat, he decided to enter a new market, black pearls. Initially, there was virtually no demand for these pearls, but after teaming up with a well-known gemstone dealer, Harry Winston, a new market began to emerge. Winston put the pearls on display in a shop on Fifth Avenue in New York, New York, and Sale began a rigorous marketing strategy, showing the black pearls on display in magazines alongside other coveted gemstones, such as diamonds and emeralds. To match the new marketing strategy, the price of these black pearls was increased drastically, making them exceptionally costly to attain. The anchor in this example is simply the high price. Once the worthless black pearls went on display next to other gemstones that were expensive and were considered high class, the demand for the black pearls increased. People began to associate the black pearls, along with the new high price, with other gems that people were already willing to pay lots for, such as diamonds or emeralds. So through the definitions and the examples discussed so far, I believe that price anchoring is truly a massively strong force that individuals and companies use to manipulate consumer purchasing behavior. Anchoring is used in real estate to sway individuals to purchase one house over another, and the same principle can be applied to smaller ticket items such as television sets. Once a consumer becomes aware of anchoring, however, in their everyday lives, they can begin to make more conscious decisions about their purchases. So to wrap up and reiterate some information, cognitive biases represent an error in logical thinking and are often observed as shortcuts in thinking, or heuristics. Anchoring is an example of a cognitive bias where a person associates a possibly random number with a possibly completely unrelated problem or task. Examples of anchoring range from manipulating what people are willing to pay for a good or service to the estimated product of a set of numbers. Regardless of how anchoring is used, it is a daily part of the life of any consumer. And only after recognizing situations where anchoring occurs can a person make a better, more informed decision.